Right, on the previous page we talked about taking a trinomial of the form x squared plus bx plus c, or ax squared plus bx plus c, where a equals 1, and we were taking that trinomial and writing it as a product of two binomials. And we're going to continue on with that discussion. So to write a polynomial as a product of factors, or to write it as a product, is called factoring. So we're going to take this polynomial, this trinomial, x squared plus bx plus c, and we're going to write it as a product of two binomials. So we have it factored. Factoring is writing it as a product. So we need to find p and q so that p plus q equals b and p times q equals c. Let's look at why that is. Because when we multiply this out, we do x times x, we create x squared. We do x times q, and there's our qx. We do x times p, there's our px, and then we do p times q. There he is. So if we combine the like terms, notice what we get. We get p plus q times x, and we get pq right there as our constant term. So our strategy is going to be based on that multiplication. So factoring, writing as a product. So we're going to look at what happens if c is positive and what happens if c is negative. So right here, if c is positive. So again, p plus q equals b and p times q equals c. If c is positive, p and q have to have the same sign as b. The reason is, if we do a positive times a positive, that's going to create a positive. But if we do a negative times a negative, that's going to create a positive. If we did a negative times a positive, it would create a negative. So they have to have the same sign when c is positive. So we're going to go through an example. Factoring when b and c are both positive. So here's our example. X squared plus 10x plus 16. We're going to try to write that as a product of two binomials, x plus p and x plus q. That's our goal, to write it as a product. So notice that b is 10 and c is 16. We've got a equal 1 up here, so we've got 1x squared. C is positive. The factors p and q have to have the same sign so that p times q is positive. B is also positive, so p and q must both be positive. Otherwise, p plus q would be negative. If they were both negative, p plus q would be negative. Think about it. -2 plus -3 is -5. If I add two negatives, I have a negative. Certainly, if I multiply two negatives, I get a positive. But if I add two negatives, I get a negative. So if c and b are both positive, then p and q both have to be positive. So what we're going to do is we're going to create a little table, and we're going to find two positive integer factors of 16 that are going to add up to 10. So I need a sum of 10. So we're just going to go through the list. So the possibilities, 1 and 16, 2 and 8. Does 3 divide into 16? No. So 3 and nothing. The other possibility is 4 and 4. Now I'm halfway there, or anyway, I've gotten to the square root of 16, which is 4. So I'm not going to go 8 and 2 because that's the same as 2 and 8. The order doesn't really matter here. They're both positive. So here, the sum of the factors is 17. That's 1 plus 16. 2 plus 8 is 10. Oh, there's the one I'm looking for. 4 plus 4 isn't big enough. It's only 8. So this is the one I'm looking for. What that means is my polynomial, my trinomial x squared plus 10x plus 16 can be written as the product x plus 2 times x plus 8. There's the factored form of our trinomial. And you can check this answer. How would we check it? we would check it by multiplying it back out and making sure we get x squared plus 10x plus 16. Let's see if we do. X times x is x squared. X times 8 is 8x. 2 times x. 2 times 8. X squared plus 10x plus 16. Okay, I'm going to pause the video for a sec. You should pause as well and try the monitoring progress. See what you can do with those. Actually, let me give you the answers on the next video. Pause the video and try the monitoring progress, and then restart the video. I'll give you the solutions. Okay, there are the solutions to the monitoring progress, complete with the work over here on the side.